So I want to show you a direct way to find the number of derangements, and it's going to utilize the number e. Let's say I want to know what d4 is. And we already know d4 is 9. There are 9 ways to arrange 4 letters, A, B, C, D, so that no one is in their original spot. So we start by saying, well, all 24 arrangements I've listed out here. Well, that has everything, derangements and non-derangements. So I want to subtract away the non-derangements, the things that have at least one thing in the right place. So this list here, in the second box, says, well, there are 6 things that have A in the right place, and there are 6 things that have B in the right place, and the other 3 letters mixed around, and now I have C in the right place and D in the right place. So that's 24 things. That's 4 times 3 factorial. The problem is, that's 24. So if I have 24 and I take away 24, I'm left with nothing. And the issue is that there have been repeats here. For instance, ABDC has A in the right place and B in the right place, so ABDC is here also. Whereas ADCB has A and C in the right place, and you can see it over here. And there are a lot of these repeats. Let's say DBCA has B and C in the right place, and there it is over there. So there are repeats, and there's even this ABCD is located 4 times. So we took away too many things because we took away the repeats. So now we need to add back in. I want to get back these things, like the 2 greens. Those things have 2 things in the right place. So that's going to be plus. There are 4C2 ways to choose the 2 things that are in the right. I'm creating that list here. There's 6 ways that I could pick 2 letters and put them in the right spot, and then times 2 factorial to rearrange the remaining ones. And now I'm up to 12, which is actually too high. And that's because I have this ABCD, which has, actually, I have it 6 times. So I have to subtract away things that have 3 things in the right place, which are over here. There are 4, well, there's really just 1, but if I say, okay, how many things have A, B, and C in the right place? There's 1. How many things have A, B, and D in the right place? Just 1. So we end up subtracting away 4C3 times 1 factorial, which is 4. But what's funny is that we have to add back in. We started with an ABCD, then we took it away 4 times, then we added it back 6 times, then we took it away 4 times. We actually never counted it. So I have to add back in 4C4 times 0 factorial, which is 1, which gets me 9. Whoops. Ignore that. So let's look at this a little more carefully. The expression was 4 factorial, 4C1 times 3 factorial, which is the same thing as saying 4 factorial over 3, 1 times 3 factorial. The next one was 4C2 times 2 factorial, which is 4 factorial, 2 factorial, 2 factorial times 2 factorial. The next one was 4C1 times 1 factorial, which is 4 factorial over 1, 3 times 1 factorial. And finally, 4C0 times 0 factorial, 4 factorial, 0, 4 times 0 factorial. If we cancel out this 3 with this 3 factorial, this 2 factorial with this one with this one with that, and we factor out a 4 factorial from everything, we get, sorry, this thing should be minus, that should be plus. That should be minus, that should be plus. We get 1 minus 1 plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial. But this thing from a previous lesson is the same thing as 1 over e. So we get 4 factorial over e, which is approximately 9. And in general, dn is approximately n factorial over e. Go ahead, try 5 factorial over e, and you'll see it's about 265, which is the same answer we got with the recursive method.